Hi, this is Tavi Greiner, Astronomy.fm's Vice President of Communications. If you enjoy our programming, please let us know with a donation to astronomy.fm/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.
Program complete. Enter when ready.
The curtain of night is drawn back. The telescopes are trained. The domes are open. The audience is set. Now, step into the event horizon.
Good evening, everyone, and welcome to the Event Horizon here on Astronomy.fm radio. That means it is another Friday evening. This one is August the 16th, 2019, about 9 o'clock in the evening, for those of us here in the eastern portion of North America. Universal time, that would put us on Saturday morning, about 1 o'clock in the morning, Universal time again. So that means we're live for the next hour. Welcome, everyone. And don't forget, come on over to our Astronomy.fm chat room if you want to get in part of the conversation that's going on there and ask us questions live on the air if you want to. How are you doing tonight, Nick?
I'm doing absolutely peachy. It's me, Nick Yvette, 2 Echo 0 Lima Uniform November. And of course, hey, Starstorm, glad to see you in the chat room. Nice to see Khan of Time. Khan! Glenn's there as well, and of course there's you and me as usual. Now, as usual, we've been posting links in the chat room. Starstorm is collecting them for us. Thank you, Starstorm. I appreciate that.
Links means when we refer to an article that news article that we're talking about. When it comes from a source, that we put a link to that source in there, so you can read the full article at your leisure if you like to. Yeah. And where will those links appear at besides our chat room later on?
They will appear in the video. Well, they'll actually appear in the information box beneath the video for the show. And that will be available through YouTube, and I will post it on my Facebook. I'll post it on your Facebook, Marty. I will post it on as many places as I can think of to post it, including Twitter. It will be on my Twitter account too, which is Nick_2E 2 Echo 0 2E0 LUN.
2E ting ting.
Yeah, very, very good. Yes. Very funny. Okay. Now, of course, welcome, Black Project. Glad to see you made it, mate.
Into our chat room.
He's in the chat room. Yeah, he's in the chat room. It's like I call everybody. Come on into the chat room. We're live, and it is fun. And
we're having a wonderful time this evening, everybody. A wonderful time.
And there's one born every minute.
There you go.
No, but seriously, before we came on the air, Marty and I were discussing the second full moon of the month, and actually,
that's what it was.
Apogee.
It was the second new moon month of the month. Second new moon of the month.
Then, of course, the full moon we've just had about a day or so ago was a apogee moon. It's the furthest away full moon. Mm-hmm. Sod micromoons, I prefer using the word apogee and perigee and syzynergy of the Earth, Moon, and Sun system. Because why? Because it is the correct astronomical term.
That's correct.
It's a bit like you saying Beetlejuice instead of Betelgeuse.
Correct. Being Beetlejuice being incorrect.
Because it's a movie with Michael Keaton. Yes. Whereas Betelgeuse roughly translates as the armpit. That's something to do with the armpit of the sheep, from the Arabic.
Yes,
and of course,
I try to add a little extra to it and do more like Betelgeuse.
Well, actually, having said that, Patrick Moore used to say Betelgeuse, because that was probably the closest to the actual correct Arab pronunciation. And of course, most of the stars, well, all the stars in the sky, mostly have Arabic names.
Mm-hmm. They do.
So if you really want to learn, it's the armpit of Orion. Yeah, Black Project is quite right. But it translates as the armpit of the sheep or something from the original Arabic.
Or the Great One or things like that too.
Yeah, there's various interpretations. The nice thing, the Arabic's like everything else. It can be slightly differently interpreted depending on which version of Arabic you speak.
And which version of any other language you speak.
Well, English is a language that likes to follow other languages down dark alleys and then mug it.
There you go. Yep.
Why is that, Glenn? Well, as I say, the only time you're going to see consistency in a language is in print. Now, if we were to take a certain holy book and respectfully open it, you would see what is considered to be. I'm not going to report that comment. The comment it might get me into trouble. Anyway, so written Arabic is a consistency. Spoken Arabic has dialects. It's kind of like someone from Yorkshire going to Liverpool, or going to Birmingham, where they all speak a bit different. Mm-hmm. So, as I say, it's down to where you speak your language depends on what words you have and how you use them.
Here in the U.S. too, same thing between like New England, Eastern New England, Boston dialect, Southern, Midwestern, Malibu dialect, we'll call it. Like I remember going down south, and somebody asked me how I pronounce the word R-E-D, and I said red, and they pronounce it Ray-Ed, but almost like two different syllables there. Ray-Ed. Yeah, it's all how you say. There's a difference in pronunciations and definitions too. So many words have so many definitions. I mean, so many of the same words have different definitions depending on how you use them. Can't think of any right now, but we've all run into those.
It's kind of like proper English and American English.
Mm-hmm, exactly.
So,
yeah, I agreed too fast on that one.
Yes, you did, Marty. Anyway, so did the Arabs have dark skies? Oh, yes. A lot of places they still do. There's actually a new telescope going into the UAE as part of the astronomical department of their university there. I won't mention who's running it because I might get thumped if I do. But as I say, so it's going to be a remote telescope. It will be accessible by the great unwashed of the internet. Mm-hmm. And it will be quite interesting.
Glenn's question, did the Arabs have dark skies? And I would say extremely dark skies because several hundred years ago or several thousand years ago, there were maybe villages scattered around Arabia. Campsites would just have a few campfire type of things. So dry air, desert air, extremely dry all the way down to the ground. So yeah, I would say extremely dark skies.
When you consider that they mapped the heavens with the naked eye, literally.
Yep.
And they got down to some fairly faint stars.
Yeah, easily 6 magnitude if you got good young eyes.
Good young eyes, good dark skies. That works nicely for me.
Indeed.
Decolab.
All right, so where were we? Oh, I know. I was going to say Betelgeuse. I got something related to that. There is a nova, new star, near the star Betelgeuse, about a couple degrees northeast of Betelgeuse. Let me put that notice into our chat room here. It's from the American Association of Variable Star Observers. I do believe it's about 9.5 magnitude, something like that. Just reported a couple days ago. Did that go in or did I mess that up? Let's try it again here. Or is my computer? Nope. Where'd that? I looked up. Why didn't it show up?
Oh, something's shown up, but I don't think it's what you were expecting, Marty.
No, I don't think so. I was looking up that word. I was like, what is that word people use? No. All right, let me put, where's the alert notice here? Let me put this in. Highlight it first. Copy it. All right, and then
Black Projects is saying Sir Patrick would be spitting feathers at Beetlejuice. You know what? So will Chris Lintop. Because I remember a very famous debate on the Sky at Night between him and Patrick about the pronouncing the name of Tycho Brahe. Even though it's spelled Tycho, as in the crater, it is actually pronounced Tycho. So yeah, okay, there we go. Yeah, he got told off.
Okay, so there's the link to the notice about the nova. It's kind of your Betelgeuse 9.5 magnitude. So look it up. And if you don't go to our links and just look up the American Association of Variable Star Observers, aavso.org, you'll find it right on the front page. Alert notices.
Now, interesting to think. Now, we all remember the big freaking rocket from SpaceX,
which is the Falcon rocket.
Yeah, we all remember the fact that one of the things that SpaceX is planning to pioneer is in-space refueling, using two of them, one as a tanker and the other one for crew and cargo. Well, guess what NASA's decided to wants to go with now?
They want to do the same thing?
They want to do the same thing.
Once a good idea, always a good idea.
Well, there's nothing new under the sun, is there really? But as I say, I'm just trying to pull this up so I can get it into the chat room. Ooh, someone sent me a like on Instagram. Nice.
Okay.
Okay, so there we go. That's the link to the Universe Today thing. And why build big rockets at all? It's time for orbital refueling. So, as of course, Tuesday the 30th of July, NASA announced 19 different partnerships, 13 different companies for to use their expertise to help them develop space technologies, from advanced comm systems to new methods of entry, descent, and landing. Now, instead like the old days where they would contract out specific projects, NASA is planning to make its employees' facilities hardware and software available for free. Of course, one of the notable of these partnerships is going to be SpaceX with NASA's Glenn and Marshall Space Centers, specifically to help advance the technology of transferring propellant in orbit. In other words, NASA is going to help SpaceX figure out how to refuel a spacecraft whilst out in space.
Right.
And think about this: if they get this little one cracked, this little nice little thing cracked out, it's going to completely change how we do missions to Mars, to the outer solar system, how we travel to the moon and the asteroid belt. Because basically, you'll just have one spacecraft that is never really going to re-enter an atmosphere. It will make the trip to its destination. It will then
potentially land.
Well, maybe have a lander section.
Yes.
And give the main. You know what? This is sounding so much like the Anastasia or Zero X. It's hilarious. But as I say, the other thing, of course, is science fiction's been there already. BBC's Journey to the Planets. They had the Pegasus. Pegasus never left space. She carried landers for Venus, Jupiter, for Venus, for Mars, for an asteroid, for a comet, for Pluto, and they basically they took the idea of using the Apollo idea of having a lander, goes in, you land, you do your mission, get back aboard, blast off, rendezvous in space, and transfer crew and samples. Whether or not you keep the capsule is up to you. Probably it will be jettisoned to re-enter and be destroyed. Hey, if you've got seismic projects left on the planetary surface, great way to generate an artificial earthquake. So, as I say, there's nothing new under the sun. Science fiction, in some cases, has done it a long time before, and they will probably be doing it even further still.
Well, has simulated it, but not actually done it. Like science fiction mostly has like unlimited fuel for the most part. You can fly all over the place and never run out of fuel for the most science fiction.
Yeah.
Or they go rise up, go land on the moon or Venus, and then go fly back to the Earth. No worries about fuel. Always happens. Something I got a question for Black Projects in our chat room here. What is the approximate percentage of fuel to cargo weight ratio? So, like, how much fuel does it take to lift up how much cargo? We'll get an idea. Because it's the opposite of, like, obviously land vehicle tankers.
Yeah.
And you've got a truck with a tank of fuel on the back of it, can drive all over the place, not use up very much fuel, and then be able to offload a whole bunch of fuel. Same thing with airplane tankers. You've got your fuel that you use to fly around, get up to altitude, and then a whole bunch of fuel can be emptied into a bunch of smaller planes. In space, it's the opposite. Most of your fuel will get consumed getting into space, and then a small percentage will be left over to fill another vehicle. So I kind of want, like, what is the approximate percentage of fuel to cargo? Can you put that, Black Project, can you put that into a percentage? I mean, like, can you lift 10% up? Can you lift 1% up? Is that it? You put some numbers in there but if we can get them down to a ratio would be great.
What he's saying is, for high thrust chemical rockets, this will likely be about 3,100 miles a second hypergolic fuels, or 4,500 hydrogen fuel. If the final mass spacecraft plus cargo is 100 tons, then the initial mass spacecraft cargo and fuel must be 212.8 tons, and that was so approximately, i.e. 112.8 tons of fuel must be carried. So
what's the percentage that we really need for this, though?
So basically, I'm not. Percentages are not my favorite. Okay, so he's saying, so this is where he's spacestackexchange.com. How does fuel requirement change with mass whilst traveling from lunar orbit? See, the thing is, we don't need to haul it all from the Earth. We have a potential source in our very low grav field that would be very, very convenient to use. It's called the moon.
Glenn's saying 100 to 1 is a ratio.
100 pounds to get 9 to get 100 pounds to get 1 to orbit.
Yep. So that would be a 1% ratio. So it takes you 99 times more fuel to get a pound.
That's assuming that you're launching from the gravity well of the Earth.
Yes, that's what I wanted to know.
Okay, I'm assuming that I'm thinking about what if you're doing the really smart thing, and making your fuel on the moon.
And what do you make the fuel out of? You can't make hydrogen and oxygen. Well, if there's enough water,
it's available now as on the moon to be harvested.
Possibly. Hasn't all been completely confirmed that there's water to do that. Suspected.
But the thing is, they're looking at the spectroscopy of the area, and in a lot of cases, this is science that's been done in lunar orbit by probes. So they're looking at the elements of the lunar soil and seeing what's in it.
But also, there's some studies have found that a lot of that water is actually basically evaporated out of that soil over time too, so there might not be as much as we think out there.
Okay, Black Projects has added some more information. Falcon 9 can lift payloads up to 22,800 kilograms. Okay, to low Earth orbit.
Okay, so 50,000 pounds, that rounds up pretty good.
Yeah, so 8,300 kilograms, 18,300 pounds to geostationary transfer.
Okay.
And when expanded, 5,500 to GTO when the first stage. Oh, okay. I see what's going on here. So basically, what they're saying is you've got a choice. You can either use all your fuel to get to where you want to go, particularly a geostationary transfer orbit, or you can husband it and really eke it out a bit. And because if you want to say, and this is what SpaceX is doing, is they're keeping some fuel back,
right,
to use so they can restart the engines for re-entry and landing.
Mm-hmm.
So if the first stage is going to be recovered, then they have a set amount of fuel they have to save. If the stage is going to be deemed expendable because it's been used, it's gone through its life, then they can actually burn the tank dry. So, I mean, and of course, Optronics is asking, well, what about water on NEOs? If they're comet-like objects, it is very possible. The other thing, of course, is where else have we detected water? Ceres.
Where?
So, Ceres, the minor planet.
Ceres, yes. There's water there, but getting there takes a lot of fuel.
But we're assuming that we're using a chemical rocket engine. What if we changed and use something that is lower power, or considered a low power option, but will allow us to boost for longer periods, like an ion engine? Because we're not now boosting liquids, we're boosting gases up.
That only works in low power rockets only work when you're already in space. So you need a high power rocket to get into space, though, and that uses a lot of fuel.
Yeah, so basically, as I say, the whole crux of it is the first thing they've got to figure out is how to safely do what they do with a Hercules aircraft or a 747 commercial plane and refuel jet fighters. They have to figure the whole scenario out. Then they have to design the equipment. Then they have to test it first on Earth. Then they have to they're going to have to do what we did with Gemini when it came to testing docking and maneuvering. They had an Agena and they had the Gemini, and they practiced bringing the spacecraft close. Then they practiced docking. Then they practiced maneuvering with the two objects joined. So here you are not only going to have two objects hurtling through local space, you are going to be trying to do a very, very delicate maneuver, because you have got a small nozzle that needs to go into a very small hole, lock in, before you can even think about transferring your propellant to the next vehicle.
Mm-hmm.
Now, the other thing, of course, is we're going. Say, for instance, we're going on a grand tour of the planets, and the Agena had an engine which could be fired with the Gemini docked as well, and that's something else. You've got to be able to maneuver the two joint spacecraft when they're refueling. Now, of course, Musk's idea originally was that there was going to be a hard dock between the two spacecraft back to back, and he was going to pump the propellant in reverse through the engine bell into the main engine, into the main tanks. That was one of the proposals that they originally came up for the big freaking rocket. Now, that would probably be a very good idea, because that way you can literally dock the two spacecraft. You've got a hard dock contact. You can then put the hopefully the two engine bells have met, and then just pump through everything like that. There should be very little waste, and everything should be transferred safely. And of course, if you are on a long range mission, then you are going to be sending out fuel tankers to various parts of the solar system to sit and wait for the spacecraft to come to dock, to probably someone's going to have to do a spacewalk to physically connect the two spacecraft to refuel. And once everything,
maybe not.
But the thing is,
remotely is always I mean, like computer controlled has always been more efficient than anything else. Was it the Russians that tried to manually connect a resupply vessel onto their space station, and they almost crashed it into the space station?
Well, up until the Dragon, I believe everything was manually docked anyway. It was only the Dragon capsule that was finally allowed to do an automatic docking, because there was always somebody ready who was there to take over and bring the capsule in for resupply on the ISS. So basically, you're either going to have one option or you're going to have both options available to the crew. So someone will probably have to put on a spacesuit, do a spacewalk, confirm that the fuel probe has successfully docked and mated, and then just wait until the propellant has transferred, confirm disconnection, and the hose is literally reeled back in, and then get everything back together.
I don't know. You could use the same docking method as they do right now. Capsules to the space station basically can be using the same type of connection with just I don't even need if they know tighter seals, but they probably need fuel-proof seals. But I don't think they manually dock, if I'm mistaken.
Well, I seem to remember watching, I think it was one of the Dragon capsules, and one of the things that the crews practice before they go on there, they actually get to go to the ISS, is manually docking the supply capsule, because that's part of the simulator that the astronauts use before they head over to Russia for the flight, is that they practice manually docking. So when you think about it, the shuttle did a hard dock, Apollo did a hard dock, and Dragon does a hard dock. Now, we could have a system where, like we do with some of the jet fighters, where a refueling probe is deployed, and then it finds the drogue, mates, and then passes fuel. So, as I say, there are an awful lot of options, and a hard dock is when the capsule itself is thrusting under power to get the actual latches to click on. Thank you, Black Projects. Brilliant piece of information there. So, like I say, there's a long way to go before we can do a refuel of a spacecraft from another spacecraft in beyond the Earth Moon system.
By the way, speaking in a similar subject, not quite, next Wednesday, astronauts Nick Hague and Drew Morgan are going to do a spacewalk, and they're going to install a docking adapter on the space station. That's all I know.
Yep. So, as I say, it's all fun and games.
Until somebody gets hurt.
Until
you
somebody
poke your
gets
eye
hurt,
out with that stick.
Well, the thing is, though, the crews do practice manual dock all the time, and that is one of the things that they have to get right, is manually docking the capsule. I think it's only recently they actually let the computers deal with it on their own. Once they were happy that everything was fine and they could go ahead with it, then they did it. Now,
with zero gravity in space, there's no up or down or anything, so you really cannot say what's up, Doc. By the way, we're about halfway through our program right now. We'll do a little station identification. You're listening to the Event Horizon here on Astronomy.fm radio, about 9:30 in the evening for those of us here in the eastern portion of North America on August the 16th, 2019. Universal time, that puts us at 1:30 in the morning, Saturday, August the 17th, Universal time. Don't forget, we got more programming coming up after the Event Horizon, 4 hours worth of programming that we will repeat every 4 hours for the next 24 hours. So if you only caught part of us, you can catch the rest of us and repeat.
And of course, tomorrow night, Well, tomorrow night for the UK, and tomorrow evening for me, I will be getting together with my good friends Neil Norman, Mary McIntyre, and we're going to have one of our old friends from the Space Watch team come join us for Comet Watch.
Nice. Will this be a live program?
This will be a recorded program.
Gotcha.
We're always recorded.
So it's going to play tomorrow evening, is what you're saying?
No, we're going to record it tomorrow evening.
Okay. Well, that doesn't help anybody listening. When's it going to play? That's what they want to know.
We should have it ready if it's been polished a wee bit, because they always need a wee bit of polishing, to go out after Pirates next week.
Okay.
Assuming you're live.
Yes. Oh, yeah, don't know yet. I might be off next Wednesday and Friday next week. Don't know for sure. It's a work thing, so I haven't heard it confirmed yet. So just let everybody know there might be a couple repeats next Wednesday and next Friday. Unless one of our other co-hosts would be available to join in, like Nick on Friday.
Keep in mind, everybody, that let me see. I'm just pulling up my calendar. The 30th is actually going to be the last show I'm doing from North America.
And so you'll have, like, after that, you'll have more of a British accent.
I never lost it.
So basically, it'll still sound the same.
Yeah, I'll probably be a little bit more out
tired
of it initially.
Yeah,
but
it
will be fun. Yes.
2 a.m.
Yeah, I'll be up at 2 a.m. Oh, yeah.
2 until 3 in the morning.
But as I say, it's going to be interesting. Lots of good fun, and of course, the really nice thing is, the Comet Watch team have been planning a special for quite a while. Now we've dubbed it Comet Watch from the Pub. I guess we decided that if it's good enough for Brian Cox, if it's good enough for Dara O'Brien to do an astronomy show, or for other amateur astronomers to do talks from the pub, why can't we record Comet Watch from the pub together, or actually around a table? Sure. Beers in hand and
glasses clinking. I think so. A few old-fashioned songs from the country, I'd say, would be just right.
Who knows? But as I say, so it's basically a case of the next after this show we're recording this weekend, the next Comet Watch will be an entirely UK recorded show, unless apart from our guests. We never know where our guests are going to come from. We have guests from all over the world. Mm-hmm. We're really lucky in that. So
just like I forgot to mention, speaking of all over the world, our chat room. Come on over to chat room. Go to the homepage, astronomy.fm. Look down near the bottom where it says chat, and come on and join us. We've got you and me there. We've got Glenn, Con of Time, Starstorm, Black Project, Cassie, and Optronics. A world audience in our chat room and listening in too.
And of course, the thing is, I know for a fact our show's listened to in the Philippines. It's listened to in Korea and quite a few other places.
Australia.
G'day, mate.
Yep. Indeed.
But as I say, the thing is, our audience is worldwide. And of course, we are, and I think you have to agree with this, Marty, we are both very much want to see an active space program. We don't want to become dinosaurs and end like dinosaurs either.
I'm getting to be a dinosaur. But
that comes to us all.
That's just me, yes. Let's see what else we got going on around town here. Let's see. Is there a launch or something? Yeah, there's a launch. An uncrewed, it means no passengers, Soyuz. Next Wednesday we'll actually launch to the space station, and it'll on the 21st, and it'll get there on the 24th. What else?
Okay, what else?
Go ahead. OSIRIS-REx.
OSIRIS-REx, yeah.
OSIRIS-REx. They have picked 4 potential asteroid sample sites for the Osiris mission to Comet Bennu. Really very lumpy, not lumpy, but rocky, loose debris. Yeah, a lot more rocks than there is smooth sand areas. They originally were hoping to find something like a nice big flat beach, like half a mile or 1,000 feet across or something like that. No, they're down to something that may be a couple hundred feet across. That would be semi-flat and with small enough particles that they could actually sample. They can only pick up stuff that's less than 1 inch. So they've got 4 candidates. They've got names for them: Nightingale, Kingfisher, Osprey, and Sandpiper. So they're going to get rid of 2 of those and narrow it down to 2, and then after that they'll narrow it down to 1, and then go in for some sample taking.
Oh, I know what I can share with you all. I found this lovely little website. It's called inthesky.org.
Oh, yeah.
Now,
I know them. I use them regularly.
Yeah, good old Dominic. Okay, let me just... So what I did, I was playing with this prior to the show.
Mm-hmm.
And there
Fun
we
stuff.
go.
It's the solar system you can look at, and you can kind of click and drag and twist it around, look at it from different angles, edge on and upside down, and from the southern hemisphere, northern hemisphere.
What you can do with this, you can set your location. So when you open up the web page, it's going to give you the rising and setting times of the sun and planets. Now there's a spanner which allows you to change your settings, and I've got this, just for argument's sake, I've got this set for New York City, and it's going to take a few seconds to load, and it will then show you the rising and setting times for. I have Venus ticked at the moment. So you can actually. Yes, Glenn, I saw that story. Not happening. The Danish government said not gonna happen. It's not a relevant story for astronomy. That's why I only went as far as there. So anyway, you can pick all the planets. You can, and then you can generally see from your location the times. I find it's a very, very nice little thing. And of course, there's an Ori. If you know what an Ori is.
Orrery. Yes.
Ori.
Mm-hmm. Which basically is a simulation of the solar system, either mechanical or computer generated.
Yeah, so this is a computer generated one.
Mm-hmm.
Okay, and you can color code stuff. You can see when it's visible in the morning or night, if it's behind the sun, or visible in the evening. You can zoom into it, and you can. There's a date slider. You can set dates. It's just this. Dominic does some very, very nice work, and he even sets a scale. He's got a scale, so every square is about 0.5 AU.
It says, but it sounds like a low-end Pokemon card. Sorry, my humor is.
That's a good one. It's the name of Pokemon.
Really,
Orcario, I'm told. Okay. I do believe they actually had an astronomical observatory in one of the Pokemon shows, so it just goes to show you, doesn't it? So, anyway, so you can zoom out all the way out to Jupiter, to Uranus, Neptune, and does it go to Pluto? No, it doesn't. So it stops at Neptune. So it gives you each square is you can see the scale for each square. That could be very true, Optronics. Very true. Let's say this is why if you're not in the chat room, you're missing all the fun, because all the comments, the jokes, and everything is in there, and you're just missing really an important part of a live show. But hey, we do our best. The links are there for you with the YouTube video. You'll even get to see me and Marty in all our finery.
Some people are sleeping, so they can't watch us during this time. It's 4 a.m. to them,
or having breakfast.
Yep. Oh, I forgot to mention something earlier. When you're talking about Comet Watch,
Yeah.
we got to talk about a comet that flew by and into the sun a couple days ago.
Yeah.
Familiar with it?
Okay. Now, I'm just pulling up my comet list.
All right.
We have a lot of comets.
Yes. I bet you won't find it on the comet list, though. Because this is a Kreutz comet.
Oh, it's a Kreutz group.
Yes, indeed. So basically, it was seen in the SOHO, Solar Heliospheric Observatory's webpage. Kreutz means it's a sun diving type of comet, and it was in one of the wide-angle viewers called LASCO. So you can actually see this comet appearing on the edge of the field of view and then flying right into the sun and not coming back out. So just go to spaceweather.com. That'd be the easiest way to pick it up and check it out. You can even run the video too. It's kind of fun.
Yep. Okay. Okay, let's have to do something on a different computer. Well, the thing is, though, there's been a lot of Kreutz group comets discovered. One of them, of course, the names of the discoverers are people like Warchok Boomplod, Zaiyan Zhu. No, I'm just trying to see Seisman Lau. Are regular discoverers of Kreutz group, Maya group, even non-group comets, even Marsden group comet. Even Marsden has a comet group named after him.
Mm.
So, as I say, and of course, if you're looking for a comet, there's only one really brightish comet at the moment, and that is Pan-STARRS 27T2. It's at magnitude 9. It can be seen from 55 degrees north to 55 degrees south. It is from the UK. It's an early morning object, and the last visual observation was in August of this year. As I say, we'll do the shipping forecast always as we do on the show anyway. But 29P Whackman has been in outburst recently, so that varies. It's normally about 13th magnitude, and it can go up 0.5 of a mag sometimes. And in fact, Black Projects has put a couple of links in to SOHO, and it shows CMEs and comets doing their suicidal dives.
Great. Got an asteroid coming by in another week and a half or so.
Yeah.
Asteroid 2019 OU1 passed by closest to the Earth on August the 28th. It's going to pass by at about 700,000 miles away from us, and this one's about 300 feet in diameter. So reasonably big and reasonably close, but no threat. So something.
Yeah. Oh, and the other thing, of course, that's one of the things that I've been talking about with some of my friends. Let me just quickly, just a second, change screens. Okay, we go.
Copy paste.
Pardon?
Copy paste.
I'm going to do that eventually. I just got to remember to pull up. I just got to remember the comet's name because. Okay, where are? Oh yes, it was D/1770 Lexel we have been discussing. Now, as I say, this is a comet that was discovered many years ago, and it's vanished. It's kind of done a Cahutex comet, really, and there's been a lot of speculation about it. It's been linked to an asteroid, 2010 JL33. Nothing's really proven. According to Gary Kronk, in '76, E.I. Kazimak Polonyanska and D.G. Saparov determined that comet Lexel was ejected into elliptical orbit with a period as low as 260 years, or maybe even a hyperbolic orbit. Now, let me just try and pull something up on that comet for us, just 1 second. Because, to be honest, I tend to go along with it's been ejected from the solar system. So, anything's possible. And so I'm just going to try and pull that up. Just 1 second. I just need to make a note of something in this typing. Okay. But it is an interesting object. It belongs to the Jupiter family. Here we go. And here's something about it.
All right.
Come on, my clipboard is misbehaving.
Is it taking its time?
Yeah, it's taking its sweet time. It's Microsoft.
Got a couple of occultations, lunar occultations happening pretty soon. Next one will be August the 24th. As the moon starts going through Taurus, it'll be occulting some third and fourth-ish magnitude stars for the 24th and 25th. And then from the 26th to the 27th, the moon will be occulting stars in Gemini. And these are all visible from like all over the world, from Africa, Australia, New Zealand, all the way up to Greenland, the middle of the U.S., Mexico, stuff like that. So a lot of occultations, because rather star-rich region of the sky for the moon to travel through.
Okay, I'm just making sure we got the link. So anyway, there is a link in the chat room to Lexor's comet. Lexor was the guy who actually computed the orbit. It was actually discovered by Charles Messier, and as I say, he named it in honor of the guy who did all his computations.
Mm-hmm. Oh, nice!
Oh, nice. It was nice of him, yes. So let's have a look at this comet. It still holds the record of closest observed approach to the Earth. However, it may have been beaten by a small sun-grazing comet, P 1999 J6 Soho. Now that approached closer at about 0.012 AU, and that was back on June the 12th of 1999.
Stop keeping track of links.
Got some meteor showers coming up. Peaking tonight, or yesterday, it was hard to say with this, the August Draconids meteor shower peaking. Let's see. That's pretty much it for this month of what's actually going to be peaking. All the ones have peaked a little bit earlier in the month. So still got one out tonight. So if you see a few extra meteors coming from the direction of Draco, way in the north, sorry, southern hemispheres, could be one of those. Let's see what else we got. Got about 10 minutes or so. Talk about a new type of supernova.
Yep, and we can have a black hole story too.
All right. This one is a new type of supernova has been discovered. One that actually leaves no trace. It's a total annihilation supernova.
Wow.
Yes, one was discovered, let's see.
More info on that.
This one was, I think it went off in November 2016. It's been followed for over 800 days, and it seems like there's nothing left over from when this thing actually went off.
I just want to thank Black Project. He's put some more information in on Lexor's comet. Excellent.
Yeah, nice. Okay.
Okay, and where are we? Oh yes, just keeping an eye on the old time, you know.
We got time. We got about 11 minutes.
So let's have a black hole story, shall we?
All right, you go.
Our galaxy's black hole has suddenly lit up, and we really don't quite know why. Now, in May, the supermassive black hole in the core of the Milky Way suddenly became 75 times brighter in about 2 hours. Now, this is known as Sagittarius A. It's 4 million times as massive as the Sun, and although no light escapes from its boundaries, we can observe the black hole's interactions with bright stars or dust clouds that surround it. So back on the night of May 13th of this year, UCLA astronomer Tuan Do and his colleagues were watching Sagittarius A using the Keck telescope on Mauna Kea in Hawaii. In a period of about 2 hours, they witnessed the black hole become 75 times brighter in the near-infrared band of the spectrum. Now, that spring evening, the actual black hole has reached higher flux levels in this year than ever measured at near-infrared wavelengths, according to a forthcoming study led by Du and published on the ARXIV preprint server. It varies from time to time like anything else does. It gets brighter and fainter on the timescale of minutes to hours. It flickers like a candle, really. But they thought they thought that something unusual must be happening this year, because the black hole seems to be varying in brightness more, reaching brighter levels than they've ever seen in the past. Now, the peak flux, meaning the most luminous phase of flare-up, soared to twice the maximum historical flux measurements. In other words, in 20 years since we've been monitoring Sagittarius A, the next brightest event has only been half as dazzling as this one. And this unusual sparkle was likely caused by a close encounter between the black hole and objects surrounding it. So the event horizon, which is the edge of the black hole, is shaped by intense tidal forces, which tears anything that gets close to bits. Once a black hole starts devouring nearby objects like stars or gas clouds, infalling material heats up at the event horizon, sparking light shows that can be picked up by telescopes. So what they think is a star called SO-2, which is about 15 times as massive as the Sun, may have been the object that juiced up Sagittarius A. Now, back in 2018, this star came within 17 light hours of the black hole, and that pass may have disturbed gases at the event horizon enough to cause the May 2019 brightening event. Now, another possible culprit, of course, is a dust cloud known as G2. That's at about 36 light hours from Sagittarius A. Back in 2014, scientists thought that G2 would be torn apart by the black hole, but results ultimately were described as boring and disappointing for astronomers. So it looks like the initial letdown may have been premature, because we may be seeing slow burn or delayed reaction to the gas clouds approach, which does kind of make sense if you think about it. At the moment, Sagittarius A is soon to go behind our sun, so it's going to be next year before we can observe it again. So they are really trying to get as much information as they can this year as possible. Maybe the black hole is waking up. There's a lot we don't know at this point, so we really do need more information to understand what we're seeing. Is it a big change in what is feeding the black hole, or is this just a brief event? At the moment, we don't know. But you know what? It's interesting to know that it just seems to be we are building more and more sensitive instruments. We're looking in these regions, and we're suddenly discovering there's an awful lot we've never seen before, and we certainly didn't know even so much about our own black hole. So I think this is going to be one we're really going to have to watch for and see what happens. Notable first, we've actually imaged the black hole. Well, we've imaged the event horizon, really, the torus of gas around it. That's the only way you can see a black hole in optical. And the other way, of course, is with radio, using a radio telescope. If I had £2 for every time someone's asked me, can you connect a pair of headphones to the dish to listen, I will probably have more money than Bill Gates. The answer is no, you cannot. It's one of those things. It's probably one of the classic goofs in the film Contact. Jodie Foster plugging a pair of earphones to listen to the tape directly. Can't do it. The only way you can see it is on a graph plot from a printer once you've actually managed to process the information.
I know what it is.
What is it?
It's galactic warming. That's what it is.
Galactic warming. Oh boy.
Mm-hmm.
I just think the black hole must have devoured Thanos and is having a burp.
There you go. That too.
Gesture for the black hole.
Yeah.
5 minutes. Where are we going to go
Yes.
for 5 minutes?
Oh, how about this mega supernova?
Mega supernova? All right, go with mega supernova.
Okay, so thank you, Black Project. Scientists spot largest supernova on record in a distant galaxy.
Mm-hmm.
A supernova, by definition, is a huge event. We're talking about exploding stars, after all. Some are bigger than others, and it looks like we've recently identified what appears to be the largest supernova we've ever observed. The event, dubbed SN2016 IET, includes a long-duration, unusual chemical signatures and more conundrums. The researchers believe this supernova could actually challenge our models of star death. So this was first spotted by scientists using the Gaia satellite back in 2016. Astronomers from all around the world have been using the last 3 years to study the information and make additional observations. In a new paper, scientists point to SN2116 IET as the largest one ever seen. It wouldn't be easy to get there, but that's not easy because it's so out of character for a supernova that the astronomers thought there was actually something wrong with the information. It exploded in a galaxy a long time ago in a galaxy far, far away. Sorry, I had to get the Star Wars reference in.
There you go.
The team estimates its distance is about 1 billion light years in a previously uncatalogued dwarf galaxy. So it formed about 54,000 light years from the center of that galaxy.
It was really far.
Yeah, and it's one of the amongst largest stars with a mass of at least 200 suns. As a supergiant, obviously its life was very short, just a few million years, and it lost about 85% of its mass during the final phase of its life. So using the MMT Observatory and Magellan telescopes, Las Campanas Observatory in Chile, they've confirmed it looks so unusual in large part due to the material ejected prior to the supernova. Yep, I am seeing what the chief engineer is saying. I'm reaching for the important, getting all the kit together. Come on, Marty, start packing up. The star formed a cocoon of matter around itself, and then the blast collided with that matter. So there's two pictures, one from September 2014 and one from July 2018. And in the September picture, they had to put a ring around the star. In the July 2018 picture, it's kind of obvious. You can see the host galaxy, and you can see the 54,000 light years between them. So this is very interesting. They recognize an example of pair instability supernovae, long theorized about, never observed. In these supernova, production of electrons and positrons inside the star reduces the internal pressure. It leads to a partial collapse. Yep, I see that. And the resulting explosion obliterates the star without leaving a black hole or any other solar remnant.
That's right.
And it can only happen in large stars in metal-poor galaxies. Well, we're down to... Okay, we've got to get out of here, Marty. So
we're not real bad. We got about 40 seconds to go. By the way, just a little bit of heat news. July 2019 was the Earth's hottest month on record so far. All right, Nick.
Captain Sagan, Chief Engineer Rob. Time to bring the away team home. Myself, Starstorm, and Marty are ready to beam up. Energize.
Indeed. Thanks, everybody, for tuning in tonight to this Event Horizon radio program on astronomy.fm. Don't forget, we'll repeat this with more programming coming up for the next 4 hours. Thanks, everybody, for joining us. Good night, all.
You.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.fm. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website, It's really easy to find us. We are astronomy.fm. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is astronomy.fm radio.
Hi, this is Tavi Greiner, Astronomy.fm's Vice President of Communications. If you enjoy our programming, please let us know with a donation to astronomy.fm/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.
There I was, doing my thing, and all of a sudden, wham! Astronomy right between the eyes.